Hello dear students, I welcome all of you to this video in which we will see GATE 1995 question asked on binary tree. The question is, a binary tree has n leaf nodes. The number of nodes of degree 2 in this tree T is, the options are given. Now this first option actually is log of n to the base 2 it is. Okay, and this last option is 2 raised to n. Please excuse me for this. So my way of solving this such problems is, look, there are n leaf nodes in the binary tree. So I draws a tree which has only one node. Let's start with this. And this is root. All of you must agree that this is leaf because this has zero children. Correct? Neither left nor right. So this is a leaf node. So number of leaf nodes n in this tree is 1. See, n leaf nodes, n is 1 in this particular example. Then how many nodes of degree 2 are present? Now by degree 2 what we mean is, a node has degree 2 if it has both the children left and right. So how many such nodes are there which have both the children left and right in this tree? Zero. Zero nodes, isn't it? So when n is 1, it seems that when n is 1, when there is one leaf node in the entire tree, then the number of nodes which have two children are 0. Let's try with a bigger tree. Just check. My way of solving this problem is that you just consider a tree like this. Now you watch that this tree still has one leaf node. The topmost node is still the root. Well, this is leaf, isn't it? Because it has no children. That means the total number of nodes in this particular tree are 2, but number of leaves are 1. So it is given if n leaf nodes, we have to take n as the number of leaf nodes. So there is one leaf node. Then how many nodes are there in the entire tree which have degree 2? That means which have two children. We again have 0. Note that root is having only one child, left child. It is not having right child. So when number of leaves are 1, then number of nodes of degree 2 is 0. Let's try again. What if I show a tree like this? Now you watch that there are two leaf nodes. These are the leaf nodes. And this is root I am pointing to. Now the number of leaf nodes, n leaf nodes they are saying, then n is 2. Then how many nodes are there which have degree 2? Now watch. This node root is having degree of 2 because it is having two children. So when number of leaf nodes are 2 in number, then number of nodes of degree 2 is exactly 1. It seems that n minus 1 is the correct option. If there are 2 leaf nodes, there is one node of degree 2. But let's confirm again by drawing a bigger tree. I'm drawing some arbitrary tree. You can also do that. Let's say that we have some sort of tree like this. Just see this. Now identify in this tree how many leaf nodes are there. This is a leaf node 1, 2 and 3. 3 leaf nodes are there. So how many nodes are there which have degree 2? Notice that the root which I am encircling is having degree 2. So this is one of the nodes, and this node which I am now encircling is also having degree 2. No other node. This node does not have degree 2 as it does not have left child. So when the number of leaf nodes are 3 in number, then number of nodes of degree 2 are exactly 2. So n minus 1 is the correct answer for this question. Let's continue GATE 1996 question on binary tree. Just check. that the question asks that if the following numbers are inserted, just see some numbers are inserted in the binary tree and the insertion is done in this sequence. That is 50 is first inserted, then 15, then 62 and so on. And these numbers have been inserted in a binary search tree. Then the question is number of nodes in the left subtree and right subtree of root respectively is. So how many nodes will be added to the left of root and how many nodes will be added to the right of root? I hope you can understand this very easily as follows. Take the first value 50. I'll just increase the font so that you can notice those values. Okay, a few things can go out of screen, but don't worry about that. See, the first value 50 becomes root because we are inserting in that order. Now, second value 15 is less than 50, isn't it? So, lesser value will go to left of root. Next value 62 is greater than root, greater than 50, so it will go to the right of root. Next value 5 is less than 50. First of all, check comparing from topmost node. 5 is less than 50, so you will visit left branch. But 15, so you will compare 5 with 15 and 5 is lesser than 15 and look at left of 15, it is vacant. So there is a place for 5 at the left of 15. 20. And 58 is lesser and 62's left is vacant, so 58 gets added here. 91, it is greater than 50 and greater than 62 and you got an empty place, the right of 62 is vacant, so 91 added. 3, it is lesser than 50, so visit left of 50, it is lesser than 15 and it is lesser than 5 also, so 3 visits, 3 goes here. 8, it is lesser than 50, lesser than 15, but it is greater than 5. So 8 goes to the right of 5. 37. 37 is less than 50, but greater than 15 and greater than 20. So 37 will go to the right of 20. 60. Check that 60 is greater than 50, but less than 62, but greater than 58. 24. 24 is less than 50, greater than 15, greater than 20, but less than 37. Correct? So 24 will go to the left of 37. And that's it. So they are now asking how many nodes are there to the left of root, left subtree of root. So number of nodes are 1, 2, 3, 4, 5, 6, 7 nodes, all in this left branch of 50. That means this entire region they are asking how many nodes are there in this left subtree? 7. And how many nodes are there in the right subtree of root? 4. So 7 comma 4 is the option. That's it. That's it for GATE 1996 question. Thank you very much.